Now, example 11 had a bit of a typo in it. It was saying the exact same problem that we already did, and we can't have that. So we are going to instead find the volume of the solid bounded by the coordinate planes and the plane x plus 3y plus 2z equals 6. Now, the good thing about a coordinate plane like that, or a plane that comes across nice and easy, is that it makes it real easy to graph, because we know that if x and y were 0, 2z would be equal to 6, so z would be equal to 3. So right here we hit at 3. 3y would be equal to 6, which means y would be 2, which is right here, right? If the x and the z were 0, i.e. if we were on the y-axis. So that gives us this piece. And then x would be equal to 6 if the y and the z were both 0. So we actually have something called a tetrahedron is what this is. When you take a plane, a diagonal plane, and you cut across the coordinate planes like that, it forms this tetrahedron. Now, we have the surface, which is the tetrahedron, right? It's technically an object, right? So we have this object right here. Now, the region of integration is in the xy plane. Actually, it's in whatever plane we want it to be. So we can put the region of integration on this back wall here, on this side wall here with x and z, or we can put it on the downward piece, which is x and y. And that, of course, is the most common one. It's the one we're the most used to, so that's the one we're going to do. So this is your x-axis, this is your y-axis, this is your z-axis. So we're going to redraw our region of integration. So here's our r right in here. So we're going to redraw that here. So we know that x is 6. Oops, x is 6. There we go. X is 6. We know y is 2. And our region of integration is right here. Okay. So now, which way do we want to go? Well, and the answer is you can kind of go whichever way you like with it. It doesn't make a ton of difference. But we have to first, let's think about setting up our integration. So for our double integral, the volume is equal to the region, the height function, dA. And again, we can do this in any particular direction. There's nothing special about the xy plane, but we chose the xy as our region, so that's fine. So we just have to make a decision then about which way we want to go, dy dx or dx dy. And you think that the height function would be useful, but your height function is your surface, which is z equals. So you have to think about this plane in terms of z. So you have to solve it for z. So if that's your plane, let's solve it for z. So let's think. 2z would be equal to 6 minus x minus 3y. So z would be equal to 1/2 times 6 minus x minus 3y. That'll just be the easiest way to write it. So that's our height. Z equals 1/2 6 minus x minus 3y. And that's what we're going to put in here. I'm actually going to stick the half out in front, but 6 minus x minus 3y goes right there. I keep trying to write 3x for some reason, but it's not. It's 3y. So that's why my x's are getting strange. Okay, so then which way do you want to go? And the answer is, well, if you have your choices, generally students prefer vertical. And there's a reason for that we'll see. So if we go vertical, that means we're doing dy dx, which is fine. I mean, we can go dy dx. No particular reason not to. So this is dy dx then. Okay, so the x values are the easier ones to figure out because the x values have to be constants, 0 to 6. Left is 0, right is 6. No problem, no muss, no fuss. The y values, you have to figure out the bottom and the top. Okay, so at the bottom of that rectangle, it will always be 0 for the whole region. So y equals 0, no problem. The top is a diagonal line, so we need to find the equation for it. So we need to know our algebra, right? Because we have a y-intercept of 2. We go down to over 6. Rise over run. So y equals negative 26x plus 2. In other words, y equals negative 1/3 x plus 2. I remember Algebra 1 class. Hooray. So this is negative 1/3 x plus 2. All right, so now we just need to integrate with respect to y. So that would be 1/2 integral from 0 to 6. 6y, take away xy, take away 3/2 y squared. And we're going to take that from 0 to the negative 1/3 x plus 2 dx. Now, 0 going in is not going to give us anything, so we're not worried about 0 going in. So where we're going to have to show the work is that 1/2 integral from 0 to 6. Okay, 6 times negative 1/2 x plus 2 minus x times negative 1/2 x plus 2, or negative 1/3 x plus 2. I don't know why I wrote a half there. It's a third. I apparently can't read my own writing. 1/3 x plus 2. And then minus 3/2 times negative 1/3 x plus 2. All of that is in our integrand. And obviously we're just going to make a computer do that. We are not going to do that. This is what Maple is for. All right, so let's go look at Maple. And here's the surface if you want to look at it. See, so it's a tetrahedron. It's a four-sided pyramid kind of a thing, but it's not. Tetrahedrons are, well, pyramids are tetrahedrons, but not all. Well, not all pyramids are tetrahedrons because we use pyramids for the Pyramid of Giza as well, and that's not actually a tetrahedron at all. But four-sided, where all four sides are triangles, is a tetrahedron. Anyway, so we find that the integral is 6. And there we go. Now, let's think. If I had given, let me just kind of pretend, if I state up here, x, y, z are in centimeters, pretend, right? So let's just add that piece at the top. Then when we find this, it'll be centimeters cubed because this is a volume.